Let's start by drawing a diagram. Here's our triangle ABC. Students are allowed to bring rulers and compasses to the AIME, but there's no need to have a perfect diagram. I'm going to make do with this. Here are the centers of our circles. I'm going to connect these centers because this segment is going to be collinear with the tangent point. So we have the distance from O1 to O2 is 2 times the common radius. And we'll draw other radii that are perpendicular to the tangent points. Since O1 and O2 are tangent to hypotenuse AB, we'll draw these radii, and we'll call these points T1 and T2. And I'll also draw this radius to the point where it's tangent to this vertical line. I'll call this E1, and the same thing down here. This is also perpendicular, and this is E2. Now I'm going to draw a perpendicular from O1 all the way down to side BC. We'll call this point D1, and I'll do the same thing over here, drawing a perpendicular to side AC, and we'll call this D2. And we'll let P be the intersection of these two segments right here. This distance from C to D1 is the same as the distance from E1 to O1 up at the top, and that's R, the radius of the circle. And then this distance from C to D2, it's poorly drawn because this is supposed to be perpendicular. Here, let me adjust this. We'll make this the tangent point. This is O2, E2, also the radius of the circle. You should recognize this triangle ABC as a Pythagorean triple with sides in ratio of 8, 15, and 17, which means the hypotenuse is 2 times 17, or 34. Also notice that triangle ABC is going to be similar to this triangle O1, O2, P. So we'll write out the corresponding ratios, the lengths of the corresponding hypotenuses. The distance from O1 to O2 is 2 times the radius, and AB is 34, and that's going to be the ratio of the lengths of the corresponding legs. So the length of the longer leg, O1P, is R over 17 times the length of the corresponding side AC, which is 30, and we'll do the same thing with O2P. BC is 16. Let's take a look at the length of AB, the hypotenuse of our triangle. Again, this has length 34, and we can sum up the distance from A to T1, T1 to T2, and then T2 to vertex B. If we take a closer look at circle O1, drawn a little more accurately here, we have A over here, and then it's drawn to tangent points E1 and T1. We'll let X be the distance of these common segments. And similarly down here at vertex B, the distance from B to this tangent point T2 is the same as the distance to E2, and we'll call this Y. So we'll substitute over here. This is X. The distance between the two tangent points is the same as the distance between the centers of the circle. That's 2R, and then we have Y. Let's find another way to write these distances from O1 and O2 to P. Because we have a perpendicular from O1 to E1 and another perpendicular from P to D2, we have that the distance from O1 to P is the same as the distance from E1 to D2, and the distance from O2 to P is the same as the distance from D1 to E2. We see from the diagram, we can break this up into the distance from E1 to A, and then A to D2. And here we'll add the distance from D1 to B, and then B to E2. Continuing over here, the distance from E1 to A, we're calling that X. And to find the distance from A to D2, since AC is 30, we can subtract the length of the radius, and then we're left with A D2. And we'll do the same thing for O2P horizontally here. This distance is Y from B to E2, and then from D1 to B, we can take this length 16 and subtract R. Let's combine these two pairs of equations, and we'll add them. And now we can use this equation. We'll solve for X plus Y to eliminate those two extra variables. So on the left-hand side, we have 34 minus 2R, and then 46 minus 2R. We now combine all of the R terms, and when we solve for R, we get 650 over 57. The problem asks for the sum of P and Q, and our answer is 737. If you'd like me to solve any other math contest problems, please leave them in the comments.